Greetings, class. Professor Williams with our Chapter 1 video. Normally in our videos, I will have Excel open and maybe AI, and we'd be doing some calculating, because that's what business statistics is, you know. But Chapter 1 is just an introductory chapter, and there is no calculating at all. We just learn some terminology and things like that. A better title for Chapter 1 would have been Introduction to Business Statistics, but it doesn't sound fancy enough, so our book calls it The Where, Why, and How of Data Collection. And I was hoping to get Microsoft Copilot to write me some good notes for this video. I asked it to. It gave me some stuff that I have used, but mostly I had to rewrite it. It wasn't very good, which makes me sad. But what's done is done. So here we go. You know, we collect data and use it to make decisions all the time. You don't have to be a statistician to do that. I went out with my wife and my young son to dinner last night at IHOP, and it was terrible and expensive. And so we've decided we're not going back. We used the data, which is our experience at the place, and made a decision, and I think it's a good decision not to go back. Now, of course, businesses have a lot more at stake than where to go to dinner. They have profits, they have shareholders to satisfy. Business statistics, this is a little one-sentence definition, involves collecting and analyzing data in order to make better business decisions. Better means more profitable. Remember that the goal of a business is to make a profit, and if they can make decisions that make more profit, then that's good. What is data? Data is anything. A collection of facts, statistics, or information that are represented in various forms. Can be numbers, text, images, sounds, and other forms. Data serves as a valuable resource and basis from which we can extract information, draw conclusions, and make decisions. Can you tell that the AI wrote that sentence? That's a pretty good sentence. I left that one in. But the more data we have, they talk about data-driven decision making. You don't want to make decisions in the dark, and if you have some data that can help you, that's good. Don't forget these notes are on Canvas right below the link to the video, so you can read them after you watch the video. Now we can characterize data in a number of ways. One is quantitative versus qualitative. A quantitative data is information that can be measured in some kind of a number. I have a little example. Points scored by Caitlin Clark last night in her WNBA game. That's quantitative. Generally, for a basketball player, you say more points is better, usually. But you can also have qualitative data, information about qualities that can't be measured with numbers, like whether Jim prefers chicken sandwich or hamburger for lunch. Sometimes you can take qualitative data and convert it into a number. Like you could say, if Jim prefers chicken sandwich, let's give him a number 1. And if Jim prefers hamburger, we'll give him a number 0. But in its raw form, the data is not quantitative. I have a couple of examples. SpaceX. I asked Microsoft Copilot to give me a couple of examples of how SpaceX might use quantitative data versus qualitative data. And these are the answers that Microsoft Copilot gave me. Quantitative data, the weight of a spacecraft. Very important, because when you're going to insert something into orbit, you need to know how much it weighs, how high the orbit is. You can imagine all those calculations these rocket scientists have to do. They certainly need to know the weight. That's something that can be measured. The more stuff they put in, the spacecraft. The more it weighs, more fuel they'll need, stuff like that. But then they might also use qualitative data. I have to scroll up a little to get the whole thing in. Astronaut feedback on a mission. Thoughts on the comfort of the spacecraft. You can convert qualitative data, as I said, into numbers. Like you could say, you could give the astronaut a survey. What did you think of the comfort of the spacecraft? Rate it from 1 to 5, where 1 is terrible, 3 is mediocre, and 5 is great. You're converting qualitative data into quantitative data. That happens quite a bit. It's easier to work with quantitative data. It's easier to manipulate numbers than it is words and feelings. In fact, you learn more about that in marketing. Consumer research is often getting the opinions of consumers and somehow quantifying it, converting it into numbers so you can analyze it better. So data can be qualitative or quantitative. How else can we talk about data? It can be, my notes are out of the screen. It can be time series or cross-sectional. Time series data, you measure the same thing at different points in time. You might want to see how it changes. And this is very, very common in business analysis. Think about just sales. How much money did we bring in today? And how much is it compared to last week? And how much is it compared to last year? You look at trends and things like that. The only way to look at trends is to gather the same kind of data at different points in time. So time series data. Another type of data is called cross-sectional data, and sometimes you'll see it just called cross-section data. It's collected from many subjects at the same point in time, often used in economics, medical, and social sciences to compare different groups or individuals. And I asked Microsoft Copilot, our favorite AI, to give me an example of time series data versus cross-sectional data, Amazon.com. So this is what it came up with. Amazon might use time series data to analyze the sales performance of a particular product over a period of time. So you might measure sales per week, each week for a year or more, and see how it's going. It can help identify seasonal trends, peak sales periods, overall sales trajectory. Now, how might Amazon use cross-sectional data? Compare sales of different product categories at a specific point in time. Provide insights into which categories are performing well and which ones need improvement. I remember I had a student who worked at JCPenney. This was a long time ago. And she was like associate manager or something. And she had a dashboard. She told me her office was upstairs. And she had a dashboard. A dashboard is a computer screen that shows data, usually in graphs and stuff like that. But it would show each department of JCPenney, how it was doing, whether it was above or below the trend. And then she could go down and say to somebody, hey, look, your sales are terrible here in the perfume section. Try to get them up, or something like that. That's cross-sectional data. Now, how do you collect data? We live in a world with tons and tons of data. And it's easier and easier to collect now that we have computers everywhere, including in the cloud. Now, the computers in the cloud are not up in the sky. They're located in someone else's building, usually somebody who specializes in storing information, including data. And sometimes it's better to let them store your data than it is to store it yourself, although you might want to have backups ready just in case. How can you collect data? 3 main ways. Survey. You can ask people questions and get answers. Experiments, testing to see what happens under controlled conditions. Observational studies, watching and recording what happens. 3 different ways. By the way, there's like more ways to collect data, but these are the main ways. This is not really a course in collecting data. In fact, our book mentions it in chapter 1 for about maybe a quarter of the chapter, and then it never mentions it again. So I asked Microsoft Copilot, give me an example of how Ford could use the 3 types of data collection. And this is what it gave me. Surveys, customer satisfaction survey. Very good idea if someone buys a new car. Send them a survey 3 months later, 1 year later. Sometimes you got to give them an incentive. You know, complete this survey and it'll give you a $10 Amazon gift card or something, right? So that's useful. They can figure out what people like and don't like in their car. Experiments, crash test dummy. That's a good one. You want to make sure your cars and trucks are safe. So you conduct a crash test. You don't want real people to crash. Put the dummy in there and see what happens. And then observational studies. This has this one about going to the assembly line and just watching people, seeing how they're doing. That's an observational study. You could also keep track of statistics that governments might keep. For example, if the government will sell them to you. A car that needs to be inspected every year. You look at all the Fords and whether they're passing inspection. Or they can keep track of their repairs at the dealership, right? They can observe how many of certain type of product are coming in for repairs. I think I could have done a better example than this. This is the Copilot example. But I think a repair history of cars is a really good one. Because if something's needing repair a lot, that was probably an engineering mistake, and you got to fix that for the next version. So once you have data, what do? You store it. And when you store it it's usually stored in some kind of a table, or at least a format that could be seen as a table to the human being. That's called a data set. To a computer, or if you looked at the raw data set, it might just be numbers separated by commas, something like that. But the idea is, if you have software that's designed to read data sets, if you import it into that software, it'll look like a table. And it'll have rows and columns, just like a spreadsheet. This is why we're going to use Excel. It fits data sets very nicely in those rows and columns. Each cell in the data set has one piece of data. You want to keep each piece of data separate. You don't want to jumble them all up in the same cell. It'll make it hard to analyze it. Data sets can be small, large. They can contain quantitative data, qualitative data. They can even contain calculations that someone else made from other data. Now, it's getting easier and easier to store lots of data, and so companies are storing more and more data and using gigantic data sets to try to gather insight that'll increase their profits. When data sets are large, it's called big data. I'm not kidding, that's what they call it, big data. And they talk about big data analysis. That just means statistical analysis on data sets that are really big. Look, I got this thing. Now, you can pause the video if you want. You might know what this is. You don't need to be a statistician to know what this is. You need to be a basketball fan to know what this is. This is a data set. Now, it's not a complete data set, but it is a data set. Here it says season, and you see how it keeps going from year to year. So this is time series data. We're looking at the same type of data each year. It says team. Look, a little logo and then 3 letters. See, if you know basketball, CLE. If you were from the planet Mars, you'd have no idea what this is. CLE is Cleveland. Then we have MIA, Miami. CLE, Cleveland. LAL, Los Angeles Lakers. And then we have FG. The thing about data is there's these acronyms, there's terminology in any specialty. FG, what is it? Field goal. 1492 shots attempted. 622 shots made. FG percent, field goal percent. 622 divided by 1492 is 0.417. That's a 41.7% field goal percentage. 3PT, 3-point shots. 63 made out of 217 attempted. 3-point percent. FT, free throw percent. OR, what the heck is OR? See, I don't know some of these. OR, DR, rebounds, I know that one. AST is assists, BLK is block shots, STL is steal. And then PTS is points. If you're a basketball fan, you know these are the stats of a player named LeBron James. This is a data set. Every basketball game in the NBA, they have at least one person who's called a statistician. Normally it's more than one person. They have to keep track of all of these things for each game so that they can put it in a data set and other people can see it. So to be a statistician at a basketball game, you have to understand basketball pretty well. In fact, in baseball, they have somebody similar called the scorer. And it's usually a journalist, a baseball journalist, because baseball is complicated, so is basketball. But this is a data set. This is time series data. Each column has a different kind of data. By the way, season is data. Team is data. This is qualitative data, the team. Then the rest of them are quantitative data. Some of them are raw numbers, like assists here. These are raw numbers. Some of them are calculated, like free throw percent is a calculation. So that's what we mean by data set. Now, by business statistics standards, this is a very small data set. We're going to work with small data sets in our course because we're doing the undergraduate level introductory statistics. If you took an advanced statistics course, and we don't happen to have one in our MBA program, but if you did, you might work with really large data sets. Data sets that are so large that you couldn't look at all the data with the human eye. They're just billions and billions of pieces of data. Statistics are calculated from data sets. A statistic is a number that's calculated from something, either another number or a few other numbers or something. A statistic is something that's calculated. It can be as simple as counting something. If you count something, like you count how many beers you had at the party last night, and you say, man, I had too many beers. I had 7 beers at the party. I'm lucky to be alive. That's a statistic. You calculated. You counted how many beers. Now, you probably forgot, though, didn't you, if you had 7? If you only had 2, you'd remember that. There are 2 major types of statistics. Descriptive statistics are less complicated. They're used to describe the basic features of the data, like what's the highest, what's the lowest, how many are there, what's the average, what's the proportion. If we look at LeBron James's data, let me go back. Proportion, right? This column, what proportion of LeBron James's shots, field goal shots, did he make? Look at some of these years, he's above 50%. Those are some good years there. That's proportion, right? We could look for ourselves. What's his highest? What season did he have the highest amount of points? Now we'd have to scan it. It would be better to use a computer to find it. I think it looks like 2304 is the highest, isn't it? 2008, 2009. These are all really high numbers, of course. If you know basketball, you know how to recognize when numbers are high and numbers are low and things like that. But that's descriptive statistics. Whoops. And chapter 3 is about some of these. We're going to do lots of these descriptive statistics in chapter 3. And then most of the rest of the book is about inferential statistics. It is more difficult mathematically. To infer is usually to try to predict. You have limited data and you're trying to predict the future. This is so common. In politics, this is an example. Who will win in November? Who will win the election? All kinds of people try to predict that. Some people bet on it. And that type of analysis is much more difficult than just counting something, right? You can count something, or you can try to predict who will win the election. In business, you might want to predict how much of your product people will buy at different prices that you could set for the product. Like if Starbucks has a new drink, they might think, okay, how many will people buy if we charge $6 for this drink? How many will people buy if we charge $5? How many will people buy if we charge $8? That's inferential statistics. And there's always error involved. Descriptive statistics, unless data is missing, you don't have any error. Inferential statistics, you can never predict the future perfectly. It's impossible. I guess if we were God, we might be able to do it. If God exists, God might know. But we can't predict it for future. So one of the key things to do in inferential statistics is to say, okay, this is what I think, but I believe there's some margin of error, and I could be wrong. And how big is that margin of error? So that's the whole rest of the book, really, after chapter 3, is inferential statistics. So I asked Microsoft Copilot to look at one important descriptive statistic that can measure how well a firm is doing, profit margin. And I said, use it to compare how well Apple is doing to how well Walmart is doing. And this is what it came up with. This is not bad. I had to change it around. I had to change some of the wording around a little bit. But profit margin, now if you have an undergrad business degree, well, you're probably not taking this course. But profit margin is profit as a percent of sales. Like for Walmart, for every $100 of things they sell, they have to pay all kinds of costs, right? Pay the workers, pay their taxes, pay the electric bill, pay the wholesalers for the product that they bought. So for every $100 of Walmart's sales, the stuff they sell, they have $97 of cost, leaving them only $3 for the business owners of profit. Now that's really pathetic. If you think about you and me, if we had $100 and put it in a savings account and just sat around and did nothing for a year, if we picked the right savings account, we would have $5 of profit, of interest. That's better than Walmart does, and Walmart has to sell all that stuff. What a pain in the neck. We're just sitting around it, looking at it just come in. So profit margin, you want to be high. So Apple's profit margin, Apple is one of the most profitable companies that ever existed. 26%. For every $100 of iPhones and stuff that Apple sells, they keep $26. That's healthy. Walmart, every $100, they only keep $3. And so if you compared just that one statistic, you would say Apple is a better company than Walmart. And you'd be right. You don't really even need another. That's just that one. The difference is so huge, 26% versus 3%. That's why Apple's stock price has gone up much, much more than Walmart's. Because the owners are like, man, keep making this profit, and we'll keep making your stock price go up and up and up. Now, inferential statistics is much trickier. The whole rest of the book after chapter 3 is about it. we're never sure what's going to happen. Sometimes we can build a probability. Think about if you're in a business flipping coins. I don't know if that'd be a very good business. But you don't know whether it'll come up heads or tails each time you flip it. But you can say, well, half the time it'll come up heads, and half the time it'll come up tails. Or if you're rolling dice, right? You're playing a game where you got to roll dice. You don't know what's going to happen, but you can think of how likely something is going to happen. That's probability. That's chapter 4. That's the first part of inferential statistics. You got to think about the probability that something will happen. And there's a couple of things that you don't know these terms. We're going to talk about them in the class. Hypothesis testing, confidence intervals. I have one example. I asked Microsoft Copilot, okay, give me inferential statistics used by McDonald's. And it came up with this. Suppose they have a new menu item, and they want to know whether people will like it. They have a null hypothesis. Less than half the customers will like it. They have an alternate hypothesis. More than half the customers will like it. And if this is true, then they would release the new menu item. And if this is true, they won't bother because they don't think they can make any money off it. So that's called hypothesis testing. And I believe chapter 9 is about hypothesis testing. There's more chapters after that we're not going to do, but chapter 9 has hypothesis testing in it. And we're going to rely upon AI to help us do hypothesis testing. We're also going to use Excel. Before there was statistical software, any statistical analysis had to be done by hand. Now, I'm not even old enough to remember that time. When I was in college, I'm 61, by the way. When I was in college, we had mainframe computer. As an undergrad, we had mainframe computer, and we had statistical software called SAS. We could program it. In the library, there were these computer terminals. We would program the software to do statistical analysis, and we would hope it would work. Because to get our printout of our analysis, we had to walk to the computer building, which was like a half a mile away. I'm not kidding either. And we would say, give me the printout. And you'd hope they would find the printout, because sometimes they couldn't even find it. But if there was some mistake, you made a little mistake in your computer code, you had to go back to the dang library and do the whole thing over again, and then walk. You get a lot of exercise. Now these days there's lots of statistical software. SAS is still around. It's much more complicated than it was. Another popular one is called SPSS. Another one is called Stata. And R. Excel is not meant solely for statistical analysis, but it can do enough for us, for our introduction to business statistics class. So we're going to use Excel. It has the benefit of being free to every student. It has enough power for us. Now, if you took a second course, now we don't have one, in advanced statistics, Excel would not be powerful enough. You would need one of these softwares, like this one or this one or this one. Any one of them would do, in order to do more powerful statistical analysis than we'll do. Now, something the book doesn't talk about at all, even though it's the 11th edition, is, it talks about it just a slight amount. Artificial intelligence. All kinds of software has cropped up now that computing power is getting greater and greater, to use artificial intelligence to help with data analysis. And I asked Microsoft Copilot to name some, and it came up with some for me. IBM's Watson, you might have seen its commercials on the TV. Google Cloud, AI and machine learning. Microsoft Azure. Amazon SageMaker. Some people don't realize Amazon, besides selling stuff, is one of the biggest cloud services. I think it is the biggest in the world. It's called Amazon Web Services. Data Robot. I must admit, I've never heard of Data Robot before Microsoft Copilot mentioned it, and then H2O.ai. Now we're just going to use Microsoft Copilot. It has the advantage of being free for us. The disadvantage is it's not specifically made for statistical analysis. If you are working in a business, you'd want to use one of the more specialized AIs and probably get trained in it to use it right. We're going to use Copilot. You might see, I'm going to make some videos. It's a little tricky to get it to do what we want correctly, but if you prompt it enough, it seems to eventually come around and get the correct results. So we'll do that. It will save us from doing some calculations, especially as things get more complicated. For things like building confidence intervals, we can have it do the calculations. We don't have to. And the human error goes away. By the way, an AI, the way I think about it, it's kind of like a tutor. You don't have to pay. That's the great thing about an AI. Now, a tutor can be really helpful for students who want to learn. A tutor can be devastating for students who don't want to learn and rather would just have someone else do their work. We have those students everywhere, including at Prairie View. I wouldn't even call them students. They're people who pretend to be students. They don't really want to learn anything. Kind of a weird attribute for someone who is in college. It's like someone who has a gym membership who doesn't want to do any exercise. But we have students like that. We have too many. And they would rather do anything besides learn. Anything. This includes paying other people to do their work, paying other students to do their work, or using AI to do their work. Now, we don't want to ask an AI a question that we do not understand ourselves. And we don't want an AI to answer the question in a way that we don't understand. If we don't understand it, then we are subservient to the AI. We're not learning anything. We're not very useful. We need to use Copilot as kind of a tutor, or for someone like me who already knows I've learned all this stuff. We didn't have any AI back then. It kind of can check my work, make sure I didn't make a human error. And what else can it do? It can do things faster than I could. At least I would hope it would. But then I have to check it. Like when I tried to have it make these notes, there were some errors and some of it was just written badly. So I had to kind of take some of what it did and rewrite the rest. So think about AI as not a replacement for learning. If it becomes a replacement for learning, we're all doomed. We're all doomed. We need smart human beings made smarter by AI, not dumb human beings who don't know what an AI is doing and all they can do is type questions and have it answer. That's part of the ethics of business statistics. It's interesting that Microsoft Copilot, this is Microsoft Copilot's slide. It put in ethical considerations, and that's good. Because business statistics, if they're used badly, can hurt people. They can hurt all kinds of people. And we don't want that to happen. We also have to make sure we don't violate any privacy rules or anything like that. When you surf the net on your phone or you use your social media, those companies are gathering huge amounts of data from you. And they're supposed to use it in a way that doesn't violate your privacy. So that's another thing to consider. And here's the last page. And this is also a page written by Microsoft Copilot. Business statistics is a crucial field in today's data-driven world. That sounds like the first slide it wrote too. It provides us with tools and techniques to make sense of data, draw conclusions, and make predictions about future events. That's exactly right. I didn't change a word of this slide. Using information is powerful, and the more tools you have to use it, the more powerful it becomes. So that's the end of the Chapter 1 video. Chapter 1 is this introductory video. Just try to get used to the terminology and because that's one of the hurdles to a new thing that you've never learned before. There are all of these terms, there's acronyms. You got to keep them straight, you got to know what they mean, then you can go on and learn more stuff. All right, so I'll see you for the Chapter 2 video. Till then, Professor Williams is saying, have a good day.